So let's get started on this first problem, problem 1. This is really some short questions about the pressure sensor range. During lecture we discussed that the particular pressure sensor that we're using is this PX409, and what I've done is extracted from the manufacturer's specification page the description of the range for the sensor and the particular model number. I also like to put the price on there so you can see what a sensor like this costs. Let me bring up, so you can see this is the sensor that you'll be using. You'll see on here it has the model number, the pressure range, that's 0 to 10 inches of water. So this is a fairly sensitive pressure sensor. I always remember that about 28 inches of water is 1 psi. So this is a sub 1 psi type sensor. And the output is 0 to 5 volts DC. Each one of these sensors will also have a serial number on here. And where that can be useful is if you want to look at the original calibration that the manufacturer provided, and I've posted those on the course log. You can look at that specific calibration to see, that was originally calibrated by someone at Omega before it was shipped to us. Okay, so this is very specific. This is for use in water. Okay. So I wanted to show you is the PX409 10W. W here designates that it's 10 inches of water. It's a gauge pressure type sensor. Output is 5 volts. So what I want you to answer here for this pre-lab, and you will submit this before lab, is just so that you're aware of what this sensor is able to read. I want you to look at the ratio of the output voltage, which is 5 volts, to the applied pressure. If you have, you can expect for your different cans, there's going to be one of these sensors mounted on each can in your 2-can setup. So just estimate what peak voltage that you expect to measure out of these sensors and how that's converted into voltage. Make sure that you specify there the can heights that you assumed in your calculations. And I want you to also go back in the MyDeck and look at whether, okay, I have certain voltage output that I expect from these sensors, and does that fall within the allowable input range for your analog inputs? That's important, and you want to see that you're taking advantage actually also of the full scale range that you have available. So these are some things that you always need to think about when you're using sensors. You want to make sure first that you're not over-ranging, but also you want to make sure that you're not, under-ranging. You want to make sure that that you're not going to have too low of a signal. In that case, you might need amplification, and so on. Okay, so this is a first pre-lab, considered relatively straightforward for you to be able to answer this one. The second problem concerns powering the sensor. And what I'd like for you to do is look on specification sheets. I have extracted the part that specifies for the particular sensor we have. This is a 0 to 5 volt DC output. This sensor requires excitation voltage, and it requires power. It's a powered sensor. It's also amplified output. So the nice thing about the sensor is you don't really have to worry about attaching any other signal conditioning. It's got a nice DC output voltage you can connect directly to the MyDeck, but you have to power it correctly. It needs at least 10 volts, and it'll take up to 30 volts. And that power supply that you send, this sensor will draw up to 10 milliamps. So you need to make sure that your power supply for each sensor can draw 10 milliamps. So what I want you to do is study the power supply specifications available on the MyDeck. Look at the manual. I've actually extracted that part that's relevant from page 43 of the manual to show you that there's 3 separate power supplies on the MyDeck. There's a bipolar 15 volt power supply, and there's also a unipolar 5 volt power supply. Each of these has typical output 15, minus 15, and about 5 volts, and they tell you also how much current each of these is able to provide. So I want you to consider that for this lab, you're going to have to power 2 of these sensors with a single MyDeck, and I want you to decide which power supply you're going to use. This is something, again, it's about you walking in and knowing how you're going to hook up your your sensor to the correct power. And I want you to explain the power requirement estimations that you're making. You know, what assumptions that you make. Can you power both of these using the MIDAC? Which power supply would you use? If not, you would tell the TA, I need another power supply. So that's another question that I want you to address. Okay. Let's go on to the last one. The first two were about the range of the sensor, the power, and this last one is, well, you now need to make the right connections. So if you look, again, I've extracted the relevant part from the manufacturer's page, and you can see for the 5-volt out, they give you a column here on the cable connections. For either the 5 or 10-volt output, you have 3 relevant cables. The NC refers to that there's no connection there. So there's a common, which is the black. The output is the signal that you want to measure with your analog input on your MIDAC, and that's going to be the white connection. And then the excitation, here's the power connection that's going to go to one of the power supplies that you select. So I want you to explain how you would connect these cables to your available MIDAC connections. And what I've done on the next slide, and there's also a link to this on the course log, it's giving you a diagram that I want you to print out and sketch and be prepared to show this to the TA. So this shows the mechanical and electrical connections on the sensor. This is the pressure port that's connected to the bottom of the can. That's already connected for you. The 3 relevant cables will be, red, output would be white, and the common is black, as shown here. And so I've also put a diagram here of the MIDAC terminal connections. What I want you to do is sketch where you're going to connect. These are the terminals that you're going to be able to clamp down these wired connections to. And what you should expect to see is, I have another photo here, I'll pop up. You're going to have the 409 cable connections ready for you to connect this way. You're going to tell the TA how you're going to hook these up to the relevant power and so on. This just shows, again, the configuration showing the connection of the sensor to the bottom of each can. And so here are the cables that you will be connecting. And draw these out. Here's your plus or minus 15-volt connections. There's the analog ground. AO is the analog output. You're not going to use those this week, so I'll give you that. And then there's another analog ground connection. And then here are your analog input and digital input and output. So sketch this out, show it to your TA, and the TA will make sure that you're ready to go. Okay. So those first 3 problems refer to the sensor, and again, the purpose of those is so that you get some experience in connecting and using an off-the-shelf sensor.